Hello and welcome to Schottky.
In today's explainer, we're going to uncover a tiny, unsung hero of the digital world.
I mean, have you ever just stopped and wondered, how do our devices process so much information in literally the blink of an eye? The answer isn't always in the big, famous parts you've heard of.
Sometimes, the biggest leaps forward in speed come from the smallest, most clever innovations. All right, let's get into it.
Now, to understand why our hero component is so special, we first have to understand the problem it solves. And for that, we need to look at the good old PN diode, which is a fundamental building block in pretty much all electronics.
See, these standard diodes are fantastic at controlling the flow of electricity, but when it comes to high-speed situations, they have a critical flaw that really acts like a brake.
This flaw is called the reverse recovery time. It's basically the tiny delay it takes for a diode to go from conducting current to fully blocking it. Now, at low speeds, it's not a huge deal, but in modern electronics, it's a major speed bump on the information highway.
So what's causing this delay? Well, it's something called the charge storage problem. Think of it like this. When the diode is on, charges are moving across the junction, everything's flowing smoothly. But when you send the signal to turn it off, some of those charges get trapped. The diode can't actually shut down completely until this little traffic jam of charges clears out, and that's what causes the delay.
But what if you could design a diode that just avoids the traffic jam altogether? Well, that's exactly what some very clever engineers did. So let's meet the hero of our story.
The Schottky Diode. This is a very special type of diode, and it's built for one main purpose: pure speed. Its unique construction lets it switch from on to off almost instantly.
So what's the secret sauce? How does it achieve this incredible speed? Well, it all comes down to a really smart change in how it's built. And this slide shows the core difference perfectly. A standard diode joins two different types of semiconductors. A Schottky diode, on the other hand, joins a piece of metal, like gold or platinum, directly to something called an N-type semiconductor. This one simple change is a total game changer. Okay, so here's how that metal and semiconductor combo creates so much speed. In this design, it's really just the electrons doing all the work. Because the metal and the semiconductor both use electrons to conduct current, there's no mismatched area at the junction where charges can get trapped. No trapped charges means no traffic jam, and no traffic jam means no switching delay. It's really that elegant.
This unique design also gives the Schottky diode a really cool nickname, the hot carrier diode. That's because when it's switched on, the electrons gain so much energy that they practically jump across the barrier into the metal. These super high-energy electrons are called hot carriers.
But of course, in the world of engineering, there are always trade-offs. Even our high-speed hero has its own set of strengths and weaknesses.
On the plus side, you get that fantastic switching speed and a very low forward voltage drop, which makes it super efficient. But the downside is that it tends to leak a bit more current when it's supposed to be off. And more importantly, it has a very low reverse breakdown voltage. This means even a tiny bit of electricity flowing in the wrong direction can damage it for good.
So, with these powers and flaws, where does the Schottky diode make the biggest difference? Let's connect this all back to the devices we use every single day.
One of its biggest advantages is just how efficient it is. Take a look at this number. A Schottky diode needs only about 0.2 volts to turn on. A standard silicon diode needs 0.7 volts. That's more than 3 times less power just to get it started, which is a huge deal in modern electronics. Because of this amazing speed and efficiency, you'll find Schottky diodes at the very heart of digital logic circuits, especially in a family of computer chips called Schottky TTL. They are an absolutely critical component in digital computers and any application where switching speed is everything.
And this quote really says it all, doesn't it? The speed of our entire digital world ultimately comes down to how fast its smallest components can switch on and off. The Schottky diode was a massive leap forward in that never-ending quest for speed.
And that brings us to a final thought. The Schottky diode is a perfect example of a small, clever change leading to a massive impact. It really makes you wonder, doesn't it? What other tiny innovations are being developed right now that will power the next generation of our technology?
If you found this explainer helpful in understanding this tiny piece of incredible technology, please subscribe to Schottky. And don't forget to like and share this video with others who might be curious. Thank you so much for watching.